Now the thing is, why do I need to know the standard error? For example, let's say we collected a population of the data set. It's not always possible to collect the population, but whatever data set that we collected, let's say that is the population. That population will have some mean. It will have some standard deviation. However, from that population we can extract or we can take out different samples. Whether it's the sample data consists of 2 data points or the sample data set consists of 3 data points, it's just out of the same population. Then we compute the mean of each sample. We plot the means of those samples, the distribution of those sample means, and then we find out the standard deviation. The standard deviation of those sample means gives me an idea about the standard error of the mean of the population or of that sample. Now, why do I need to know the standard error? Whenever we compute sample mean, we may have to answer one of the 2 following questions, right? We have a data set, whether it's a population or it's a sample, we compute the mean, then there are 2 very basic questions, either or. Either I answer the first bullet or I answer the second bullet. If I don't have any control over the sample size, whether it's a 10, whether it's a 20 data point, whether it's 30 data points, what is the confidence of mean? How confident I am about the mean that I have computed for that sample? And then let's say, if the size of the sample can be controlled, I'd say, okay, I have collected 10 data points and then those 10 data points are fine, they are enough, they represent the population, I am fine with that. Is it true? Is it so? What should be the size of the sample? How much data points should I collect so that the standard deviation is low? Standard deviation of the sample, of the means of all the samples that I can draw out of that population is enough. That these 2 answers, knowing the standard error, is important to know, to find out, to determine the size of the sample that we need to collect for our study. So let's say this is a simple. I drew this so that it becomes clearer, it becomes easier to understand the concept. The answer to the 2 questions that we asked, that how confident about the mean, if there is no limit on the data set, how confident I am about the mean of the data set, and if I am confident about the mean, then is the sample size enough? What should be the sample size? So to answer those 2, here comes the concept of standard errors of the mean. Let's say this orange or this red circle over here, it represents the population. Or population, now here when we talk about population, that does not necessarily mean that population of the whole world, or we are talking about the whole universe. It could be the class. The class could be the population. Like let's say 10 values that we collected, we are calling it as the population. Then out of that population, I can draw out small samples out of it. Now these small samples may consist of minimum of 2 data points and maximum of any number of data points. I draw out small samples out of this population, and then this distance, so the standard deviation of the mean, and then I find out the mean for each of these small green circles, or the mean of each sample. Then the standard deviation of the mean of these samples from the population mean is called the standard error. Clear? Is it clear now? The concept is it a little bit clear to you now? What the standard error is? No, of course. Okay. Sure. Let me repeat it. See, and then I have an example in the following slides that will make the concept more clear. See, we collect a population data set. We collect a sample of the data set. Let's call it the population, right? For example, I collected the height of 100 students in the class. That is my population. Out of that 100 students, I can take out different samples, right? Groups consisting of 5 data points, group consisting of 10 data points. So this is the whole population. of the 100 students in my class, out of those 100 data points, I can have several combinations of the sample. So let's say I took out sample of 3 data points, then I took out the sample of 5 data points, then I took out the sample I considered a sample of 10 data points, and I calculated the mean of each sample here. The mean of this green circle, these are the subsets. These are the samples that are drawn out of this whole population. Is it clear till this point that this orange circle represents the population and these? Okay. Then I compute the mean of each sample data that I have. So let's say this is sample data 1, I computed its mean. This is sample data 2, I computed its mean, so on and so forth. Then I plot the distribution of all these samples, okay, like the way we plotted this frequency distribution. I plot the distribution of the mean of those samples, and then I computed the standard deviation. So the standard deviation of the mean of these samples, the standard deviation of the means of these sample data sets from the mean of the population is called standard error of the mean. Clear? Okay. See the standard, this black circle, this big black circle is the mean of the population. These small green circles are the samples, and each of these sample data sets have a mean. So let's say, for example, for this sample, let's say for this sample, yep, here. For these 2 samples, this is the mean. This line is drawn at the means of these data sets. Then the distance between, or the standard deviation of the mean of these sample data sets from the mean of the population is called the standard error of the mean. We compute this standard error of the mean so that we know how confident we are about the data. How much more sample, how much more data points do we need? It gives us the number which is called the sample size, and we'll see the equation. We'll discuss the equation of the sample size in the following slides. But is the concept clear to this point now, all of you? Okay, thank you. Now let's do it. I wanted to scan few things for you, but my scanner unfortunately wasn't working. Yes. If you don't have the finite population size value, which means, so in other words, you means that we have the infinite population size? That is what you mean? Well, in practical, it's not possible. What do you call infinite? See, infinity is it's something that you cannot define. How do you know that it's an infinite? We can spend our whole life collecting the infinite data set, but yet we won't be able to collect the infinite data set. Of course, the sample is finite, of course, because something that we can count is finite, something that we can contain is finite. Even the population, infinite population, no, population can be finite and infinite as well. However, claiming that the population we have is infinite is not correct, because the population of this whole world, the 6 billion or the 7 billion number that we have, we are able to count it. So it's a finite population. However, if we say the number of stars in the sky, they are finite as well, but we are not able to count them. Maybe one day we might be able to count them, but not yet. So we say there are infinite stars in the sky, something that we are not able to count. How could we count mean of the population? Well, let's say that the population, when I said population, it does not necessarily mean that this whole world only. The population, you can say that the 10 data points you collected is the population. It's your population. And then you take out small samples out of it. So, or the data set that we were just discussing of 100 students is the height of the population of my class. So we can compute the mean of it, can't we? Standard error of the mean, why not? Like standard error of the means of the samples. See, okay, yeah, I knew that this concept will be difficult, a little bit difficult. Standard error of the mean, or standard deviation of the mean of the small samples that you see when we collect the population data set, right? Okay, let's see here. For example, I collected the ages of some of a class that I am attending, not a class, of the group of people. Now these 5 people are the population that I'm talking about, right? Then I will have some mean of that population. Now what is the standard error of this mean? How deviated is this mean of the sample from the population? So standard error of the mean, when I say, see, this is the population, this red circle over here is the whole population data set that I collected. Now it has some mean. Then what is the standard error? If I take out the small samples out of it and I compute their mean, or let's say not only mean, but if I compute the standard deviation of the means of these small samples, then what is that standard deviation? That standard deviation is the standard error of the mean. Clear? If it's no, say no. Then we can go over this concept again. Okay. So what are we not understanding here? That the terminology, standard error of the mean. Okay, let's say that this population represents the. Okay, are you sure, Usman? Just don't say it because you want to like get over it. You really need to understand this concept. So, okay, you haven't understand it. Okay, let's say this red circle here, it represents the population of the 100 students in my class. Okay, agreed? Now I want to know that, and it has, out of that population, I can have several combinations of 2 students, 3 students, 4 students, 5 students. Because we want to break down our data sets, so to find out the internal standard error into it. What is the standard error of the mean? How much the mean is deviated? So what we did is, out of that population, we took several combinations, several small subsets. Those subsets we are calling as samples, right? Population is a huge, it's a big data set, and then the taking out the samples or the small subsets is the sample. Now, we want to know that how these small samples that are taken out, that very population of the 100 students, each of these samples will have a mean. The standard deviation of those means from the population mean tells me the standard error of the mean. Standard error of the mean. See, standard error of the mean of the samples that we drew out of that population. We want to validate our data sets, right? We want to verify our data set. We want to know the data set that we have collected, the population data set that we have collected, how good it is, how bad it is. Now, to know that what we did is we divided our entire population into small data sets, in small samples, and then we computed the means of each of the sample. Okay? So if